Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today, my guests are from Skyera. We have their CEO of the company, Radislav Danilak, and Tony Barbagallo, VP of Marketing at the company. So, gentlemen, welcome to the show today.
Thank you. Thank you.
Well, great. I brought your slides up. Why don't we start with that? We'll do an overview of the company, and then we'll do a short Q&A.
Sounds good. But basically, the company was Rado started the company, and the goal is actually to bring flash-based solid-state storage to the mainstream enterprise. That is a very ambitious goal, but one that we feel that we can achieve, given the diverse backgrounds of the company founders and the core engineering team. Rado and team actually developed the SandForce flash controller, which is in use in arguably over 80% of the market today. And there were some great advancements in that technology, but essentially this is really taking that technology to another order of magnitude to be able to bring consumer-grade flash to enterprise storage. Some of the other team members include Frankie Rupavar. He was a COO of Micron, so we have some flash experience. Dave Martin, former CEO of Hitachi Data Systems. So with storage experience, we have Roy DeCruz and Alessandro Finn, who bring us networking and deep flash level experience to the team, and a group of software developers with storage and file system experience. And of course, you need that diverse skill set if you're doing what we're setting out to do, which is building a flash-based enterprise storage array from the ground up. So building our own RAID controller and flash controller and flash-based storage blades to get the kind of performance that's required for enterprise storage. And this is just to give you kind of a notion of where flash has come and the evolution of flash in terms of its growth in the enterprise storage space. And really the goal for enterprise usage is roughly a 5-year life cycle for enterprise. That's usually the standard, the replacement cycle. So with single level cell flash, at an end user price of anywhere from $20 to $25 a gigabit per native usable capacity, you get about 200, 300,000 writes out of that technology, and that is roughly suitable for enterprise lifespan. Again, though, that cost is really relegated that type of solution to the highest end fringe applications in enterprise storage. Enterprise MLC came on the scene, and the rough end user price for that type of solution is in the $7 to $9 per gig range. Again, much too expensive to really break the price barrier to mainstream enterprise adoption. And essentially, the only technology on the market today that can do that is this consumer-grade flash. So that's very similar to the flash that you would find in a USB key that you would purchase at your local electronics store. So given that price barrier at roughly $3 per gigabyte native capacity, which leads to under $1 per gigabyte after compression and deduplication is really what would be defined as true price parity with today's enterprise based spinning disk storage systems. And the next slide, slide 5, really talks about the technical challenge, though, with consumer-grade flash. So it's one thing, obviously, to hit the price point. And one of the things I need to continue discussing is that single-level cell flash, SLC, gets the 200 to 300,000 writes. EMLC gets about 20 to 30,000 writes, and that's really what propelled the SandForce technology to give that flash-based memory, about a 10x life amplification improvement to get it to the enterprise endurance standards. When you get to consumer-grade flash, we're only talking about 1,000 to 2,000 writes before the media fails. So the challenge is, how do you get 100 times life amplification out of that flash media? And that is the technology hurdle that needs to be solved. Obviously, the cost is appropriate for mainstream enterprise, but it's really about the technology hurdle. And that is really on slide 5, where to get the 5-year lifespan out of a consumer-based flash storage system requires the controllers and the entire system to squeeze 100 times more write endurance out of the technology. So 100 times more life amplification. And that's basically what we've done here at Skyera. Slide 6 is essentially introducing the first version of our product in that technology. So 100% consumer MLC flash, the size of a pizza box, and that includes an integrated network switch. So in a half-depth 1U blade form factor, we've been able to squeeze 44 terabytes of usable capacity, and by the way, that's before any compression and deduplication, into that form factor. In addition, we've included 40 essentially direct network connections, gigabit Ethernet connections, as well as 3 10 gigabit Ethernet uplinks. So the storage array could either function as a directly connected network storage or as an end storage node off of an iSCSI protocol. The system architecture, again, we've taken a complete system approach from the flash controller, which contributes to overall life amplification, new and patent pending error control algorithms, ECC, error control and correction algorithms, a new RAID technology that works in conjunction with the flash controller, as well as compression and deduplication done in hardware. Several of the vendors that offer compression and deduplication today on the market, that is actually done in software. So there's potentially performance hits that you would pay for that. So our hardware-based compression and deduplication does not incur any performance penalty. And then on the software side, we include what you would expect from a traditional block-based storage solution, including snapshots, writable clones, consistency groups, a complete web-based interface that shows everything that you need for performance monitoring, LUN creation and management, thin provisioning, being able to resize the storage groups, etc. Well, slide 8 just gives a quick example of one of the user interface consoles, one of the views of the many that are there. And then the next 3 slides, slides 9 through 11, turn over to Rado to really talk a little bit more in detail on what we've had to do in terms of the technology stack to really optimize the life, to basically extend the life of consumer MLC.
So, to achieve 100x improvements in life amplification, there is no single magic bullet which you can deploy. It's sum of multiple techniques. Some of them improve things like 2x, 3x, some 1.5x, and many techniques stacked together, their effect multiplies to get over again more than 100x. So it has to start with the flash device itself. We are manipulating device physics, playing with voltage shaping. Of course, we have to support adaptive read and write, and we have to start at the bottom of the technology stack. Perfect understanding of the flash, and it's underlined by having basically on our team effectively father up MLC NAND flash, who commercialized first time MLC NAND flash, Professor Ken Takeuchi, to Frankie Rupavar, which was behind the design and development of key technologies in Micron. Now, once we extract maximum what we can from consumer grade flash, the next level is the controller itself. Of course, we have to do even more advanced DSP processing and adaptive improved ECC, new ECC scheme, which are way less efficient from the gate count and ECC gains. Now, controller talks to the RAID. If you take conventional hard drive RAID systems, which you need them for reliability, for example, RAID 6, if you are having random writes for every data which you have to return to RAID 6, you will have to upgrade P&Q writes of the RAID 6. So for every write, random write, you produce like 3 times more writes, and which is okay for hard drives, which they don't have limited endurance. However, for consumer grade flash, that's not acceptable. So we have to develop new RAID technology, which has write amplification much lower, close to 1. Now, that technology requires basically cooperation between controller and RAID, and we had to simultaneously develop new generation of RAID SE for solid state and new controller which is able to work with that, and we had to use internal proprietary protocols. Now, moving north of the stack on the system level, certain technologies like, for example, deduplication, they just simply don't work on the controller level. They work only on the basically global level, and we introduced the hardware deduplication, and also, as many systems in the past, of course, on the system level, introduction of compression is very important, and especially to not have any performance impact, it has to be done in the hardware. And we introduced some few other techniques on the system level which minimize writes. So overall, having complete vertical knowledge and technologies from effectively flash wafer to the application allows us to take a lot of benefits and synergies which otherwise was not achievable. If you just buy existing pieces and technologies and you connect them together, they don't provide much synergy. So the system what we built is built for the flash, the way how it should be built for the flash. It's not a retrofit and pieces from existing disk-based storage system. It's just built for the flash media.
And then I had already mentioned this before, but slide 12, the last piece of the equation is really to connect the network switch with the storage. And the reason why we did that is basically in a spinning disk world, the network is much less of an issue in terms of a bottleneck. But when we get the additional performance out of flash-based systems, that can actually tax an iSCSI-based network switch. So, like I said, we can certainly be that end storage node. However, we also have the capability to directly connect up to 40 servers to the storage array, and that again removes one additional piece of the bottleneck between storage and application. Slide 13 just gives a little bit of a pictorial view of our density capacity. You can see at the very left a couple of full height 44U racks to achieve reasonably performing spinning disk system enterprise storage. Some of the solid-state storage systems on the market today certainly are much smaller and more dense than traditional storage solutions. But as you can see, you get down to our first product offering at 44 terabytes and a half depth 1U form factor, and we're significantly more dense and have more capacity, and again taking up much less rack space. The downstream improvements are huge in terms of power consumption, administrative costs, etc. But even with those that total cost of ownership benefit, still the real price barrier is that upfront cost to enterprise, to flash storage in the enterprise. And again, that's really what we've addressed here. And then slide 14, just a little overview on pricing and availability. As I said, our goal, and we've achieved this, is to break the $3 per gigabyte native usable capacity. Our 44 terabyte solution has achieved that, and again with compression and deduplication, we're as low as 99 cents a gigabyte. In terms of availability, we'll be demoing the product at Flash Memory Summit, August 21st through 23rd in Santa Clara. We plan to have an early access program commence in September and should run through the end of the year with general availability in early 2013.
Well, terrific. Well, thank you for that, Tony and Radislav. Couple questions here. You know, it seems like the flash space, for at least for enterprise, is crowded. If you had to give me the elevator of why Skyera, what would you say?
Let's start looking from the economy angle. There is a large group of the companies which they are just buying the SSDs. We know who they are without naming them specifically. The problem with that is that somebody has to build an SSD, buy the flash, make his 50% gross margins, and you have margin stacking. Second, if you buy the SSD and you don't own controller technology, you are dependent on what kind of flash technology the SSD can support, and you don't control your destiny to give best price to the customer. So this is the largest number of the today SSD players. Just take off the shelf SSD, take off the shelf controller, take off the shelf x86 system, license some software stack, slap that together, and basically show it. The very small group of the companies are who they own and have the controller technology, and they can buy just flash and build the system, so they don't have margin stacking problem. That's very small group. Within that group, where there are effectively only 3 players, including us, basically the other competitors, they have limited flash capability and knowledge. They partner with some flash vendors, and their knowledge is basically limited to that information. And a lot of system level benefits, basically they don't see. Another aspect is that companies with their own controller, these are very simple controllers. On the system level, they don't provide capabilities like hardware deduplication, or on the system level compression and many high level features from snapshotting and clones. So that's a very significant differentiation from the customer point of view. And from the cost, to enable using consumer MLC, very low cost one, you need certain capabilities which you cannot find in any other company than the Skyera. So while other competitors can build the system and sell it, they cannot build that for even comparable price. We are building system for fraction of the price because technology enable us to use consumer grade MLC, and you don't have any other company with that capability currently.
Okay, well, terrific. That's helpful. So Tony, question for you. As you guys go out there with this early access program, what are your biggest challenges as far as when you pitch this? Are they already sold that flash is the way to go? and you have to convert them to your mix of technology and cost, or what would you say it would be the big challenge for you?
Well, we are taking a measured approach to introduction. So we are focusing initially on companies that are have sort of big data type of analytics challenges. So vertical markets include the oil and gas industry, life sciences, media and content delivery types of enterprise customers. So those organizations have demands in terms of performance and capacity. So obviously, oil and gas company that's analyzing soil and other geological data, that's just a lot of data. Same way with life sciences. So their need is around high performance storage and lots of it. So not just high performance storage. And those are the organizations we're going after. And those are the types of target markets that really need a solution like ours, and there really isn't one for them today.
Well, terrific. Well, gentlemen, I'd like to thank you once again for coming on the show today.
Thank you.
Thank you.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on cloud computing.